So this is the first lesson on machine learning. It assumes you know nothing about machine learning. What is machine learning all about? It's about making predictions. Google uses machine learning to predict whether you'll click on an ad or not. The same for Facebook. Netflix uses machine learning to predict whether you will like certain movies or not. Um, your email spam detector predict whether a certain email is spam or not. Banks use ML to predict if a transaction is fraudulent or not, right? So it's all about making predictions. The example that I have today, and I will walk you through it, is about predicting the value, the price of an apartment. So this could be useful if you are a real estate app like Zillow or a real estate investment firm. Given certain information about an apartment, you want to be able to predict the value of that apartment. Now, here I have only the size of apartment, and I'm going to use only that information to make predictions. But you might imagine in real life scenarios, you would have a lot more attributes or features about those apartments, like the number of rooms, location, so on and so forth. Here, for simplicity, we're just going to pick apartment size. Now, if everything works well, you would be able to give it the size of apartment, like 1,200 square feet, and then it will give you a prediction value of $210,000. Now, for model to be able to do all this, you've got to train that model. And so the way that works is you create a data set of uh, apartments and their known prices, right? So this could be historic values. You go to the market, you do your research, you find that, yeah, the apartment that was 1,000 square feet went for 300K. Another one, 1,100 square feet for this amount. And then you will end up with a whole bunch of data points. And this is what we call training data. This is what you're going to feed into your model to learn the patterns or the relationships between the sizes and the prices. And I created a toy data set of 100 data points. Here you can see on the horizontal axis you have the size, vertical axis you have the price. Each dot represents an apartment, right? So I've got all this data, I feed it to the model. And what makes machine learning is that the model algorithms are able to identify the relationships or the patterns between the input and the output, between the size and the price. Now, the other paradigm, if you didn't have machine learning, the alternative would be for you to find that relationship however you can and then hard code it somewhere, create a rule engine. But in the world of machine learning, the algorithm does that for you. Now, the one thing that you as a developer need to do in machine learning is to determine what kind of algorithm you want to use, what kind of model. And then the training process will be about tweaking that algorithm to best fit your data. Now, I look at this and I'm like, there's a clear linear relationship between price and size. So I'm going to go for a very simple type of model, very simple algorithm that's called linear regression. Linear because it makes a linear association between the two, and regression because it's trying to predict a continuous variable. So once you train the model, you end up with something like this. The blue dots again are the data set that you use to train the model, and the green line represents the model predictions. And so before I train the model, if you recall, I mentioned you have to pick what type of model you want to use, what kind of algorithm. And I mentioned I'm going to use linear regression. So the equation on top left is the equation of the line, if you remember from middle school math, where y equals a parameter times x plus another parameter. So the whole process of training the model is essentially finding the optimal values or the best values for A and B. In other words, for model parameters to best fit the training data set. In other words, find A and B such that this green line has the best approximations of the blue dot. And it just so happens that the value for A would be 103, the value for B would be this. And now that you have this equation complete, now that you know the value of your parameters, you can just plug in whatever price you got, and then it calculates, I'm sorry, whatever size you got, and it gives you the corresponding price. That's how it makes prediction. And I want to make a general observation here, which is, for the most part, all these machine learning models are just equations like this. Or it could be a much larger equation. Nevertheless, they are equations with parameters in them. And the whole purpose of training the model is about tweaking those parameters, finding the best values of those parameters such that the predictions are closest to the actual values in your training data set. Now, in this case, you have only two parameters that the model needs to find, right? But in like GPT-4, there are over 1 trillion parameters. So that's why training GPT-4 takes such huge amount of time, compute, and data, because you're not trying to tweak two parameters, you're trying to tweak over 1 trillion parameters. Now, I'm going to show you the code, and that will, to show you how trivial the implementation of something like this could be. Right? So I create my data set. You don't need to worry about that. That's just data manipulation. I'm using Python, by the way, which is a very popular programming language for data science and machine learning. The good news is that it's very high level and easy to understand. This 3 lines of code is essentially all you need to do to train a model. So let me walk you through it. The first step is you go to a library, and library is a bunch of code that the community has written so that you don't have to write it from scratch. It's a way of sharing and leveraging each other's work. So I'm like, go to this popular programming language, library, and from the family of linear models, pick this type of model for me, linear regression. And now I'm saying my model is of this type. I'm going to have a linear regression model. And that's how you train it. Fit or train are used interchangeably, mean the same thing. I'm like, this is my input, this is my output. Each of them is an array of 100 values because my data set has 100 elements in it. So the sizes are like 200, 410, 620, just an array. And then the prices are like 220,000, 240,000, 100 values. So the first element of the sizes corresponds to the first element of prices. You feed it to the model and you fit the model essentially. And if you recall, the model is just an equation here, equation of a line with 2 parameters, right? You got the slope and you have the intercept that defines that line. So if I run it, it says this is the intercept and this is the slope. And that's where I got my values from, by the way. You remember this? And now you have that equation ready to go and make predictions. And here, I'm going to make a prediction for you. So suppose the size of the apartment is 1,200 square feet. You call that model, you ask the model to make a prediction. Predict the price of an apartment where the area is 1,200 square feet price, and then print it. And it tells you the predicted value is $321,000. One thing I want to bring you to your attention is that it took very little time for the model to make prediction. In this case, 2 milliseconds. But if I keep repeating like 0.3. It changes a little bit, but it shows how fast it is. Why is it so fast? Because all it's got to do is to plug in that size value into that equation that I just showed you and give you the price. That's why it's so fast to make predictions. The other thing is, if the model is just an equation with two parameters and a bunch of metadata about it, it should be very small in size if you wanted to store it in memory. And that is actually true. It is 429 bytes. That is a very, very small memory footprint, right? Now, the information here about the size and how long it takes it to make prediction is to highlight one fundamental concept here, which is the models don't retain the training data. It's not like a database that it keeps the data, and then when you make a prediction, it will query that database and return anything to you. The model has only learned the patterns and retains information about the pattern, which in this case is the intercept and the slope. So once you train the model is very separate from that data, has no retention of that data. And for that reason, you can see that making prediction is so quick and the model size so small. Now, as a matter of fact, if you had 10 times as much data set for training, these things wouldn't change. You still have this much data, this size of memory, and this amount of response time. And I can show you. So I had 100 data points in my initial try. I'm going to make it 10,000 data points. You can see I have a lot more. Well, let's train the model again on all of this. You see how fast it trained, first of all, which means not all machine learning stuff is time consuming and resource consuming. It really depends. But also, let's make a prediction again and see how long it takes. You see 0.4 millisecond again. In other words, the response time of the model hasn't changed. And the model size also shouldn't change. Why? Again, because the model was holding only this equation and not the underlying data that was used to train it. I hope this was useful.